Hey everybody, in this video we're going to be talking about statistics, which I know is the reason why you all signed up for AP Psychology and you're really excited about it. Just kidding, I know none of you signed up for it because of all the math and data analysis that we're going to have to do. But why do we cover statistics in psychology? Well, we've been talking about research this whole last week, and if psychologists are going to do research, they're going to get data, and we need to know how to organize that data so that conclusions can be drawn from that data, and so it's really important. It's also important because this whole class is really structured on psychological research that we found out over the years, and it's important to be able to critically analyze that data to see, is it still valid today, or are there changes that we need to make? So psychological data can be shown in many different ways. Pie charts, histograms, bell curves, but it's important to know how to read data because it's very easy to manipulate people by the use of data and how you show that data. So for example, if I'm looking at this graph here on the left, I would say that I would never buy brand Z. Brand Z just seems totally bad compared to our brand or even brand X. But if I look at this graph over here, there's really not a whole lot of difference to me between our brand and X, Y, and Z. But they're really the exact same thing. They've just been shown on different scales. And so just by the way that I show this data, I can influence the way that someone interprets the data, just us drawing false conclusions or getting them to believe whatever I want them to believe. And so we're going to learn how to try and really notice those things in data. So here's kind of our outline for the video. We're going to be talking about two main things, descriptive statistics and inferential statistics. Descriptive statistics are after you do your own individual study, that's the data that you produce from that study. Inferential statistics is data that we've taken from a study that we're now trying to apply to whole populations, right? So if I do a study on Bethel High School seniors' ACT scores, and then I publish the data, that would be descriptive statistics. But if I try and generalize that data for all area high school seniors like Tipp City and Wayne, or just all high schoolers in general, then that would be called inferential statistics, and it has to meet certain requirements, i.e. statistical significance, that we'll talk about today. So let's start with descriptive statistics. The first part of descriptive statistics are called measures of central tendency. So after you do your own research, you're going to produce these measures of central tendency. And all that means is that these are one number that will generalize or represent all of the data. And there are three of them. There are the mode, the mean, and the median. And hopefully you guys know what these are from math class, but just in case, mode is the most common number in a data set, mean is the average, and median is the middle number. And these numbers can be good for describing data because they give you one representation of all of the data. So if I give every junior and senior the ACT in Bethel, and then I get the average score, I can compare that average score to Tipp City, Tecumseh, Wayne, and see how do we compare. It's a lot easier to do that with one number than compare every single set of data with every single set of data from each of those schools. And I can do the same with the mode and the median. So right now I want you to practice really quickly. I want you to stop the video and I want you to try and find the mean, the median, and mode of all these numbers just to make sure that you can do it. And here are your answers. So mean is 7, median is 7, and mode is 6. Now the mean, median, and mode work really well if your data follows what we call a normal distribution or it forms a bell curve. And what this essentially means, if your data forms a normal distribution, is that about 68% of everybody in your study or 68% of your data points fall very closely together. They're almost the same. Okay, we say they fall within one standard deviation of each other, and I'll get to that later. But then you have about 15 or 16% on either end that kind of fall within the outliers. So in a perfect bell curve like this, your mean, your median, and your mode are all the same. They're right here in the middle. So this is the most, you can see if it was on a bar graph, this would be the most of your responses are right here. This is also the middle number because 50% fall on both sides, and it's also the average. And we find in life that many attributes fall in a normal bell curve. So if I were to take the ACT score of every person here at Bethel, we would find that statistically it's more than likely to form what we call a normal distribution, where 68% of the scores are going to be really close to each other, and then you'll have the extremes on the high end and you'll have the extremes on the low end. We find that this happens with height in groups. So if you're to take the height of everybody in Bethel, 68% of people are going to fall usually within each other. And we're going to do an activity tomorrow in class that kind of proves this, this normal distribution. And the problem with the mean, median, and mode is when you have not a normal distribution, you have a skewed distribution. So the graph, instead of looking like that nice pretty bell, could look something like this, where a lot of our people are on the high end of the spectrum, or like this, where a lot of our data is on the low end of the spectrum. So an example would be if these were test scores, and here is 50% right here in the middle. Now this means the majority of my students scored over 50% on their test. They did well, and only a few did very poorly. Over here, the majority of my students did very bad on a test, and only a few did very good. So how does this relate to mean, median, and mode? Well, let's use The Office as our example. Okay, we've got Dunder Mifflin. It's a very good company to work for. They're advertising. They want to hire some more people. And so here's the data that they have. Here are the salaries of everybody at Dunder Mifflin. And so if you were to take the mean, median, and mode from this data, it's actually kind of misleading. So for example, the median salary is $80,000. That looks good. The mean salary looks pretty good at $93,000. But when you actually take the mode, it's only about $25,000. So what Dunder Mifflin could do is they could say, hey, come work for us. The average salary of our employees is $93,500. But really, are the majority of their employees getting $93,500? Are that 68% getting that? No, they're actually getting under $93,500. But because this graph is what we say positively skewed, there are a couple of really high positive salaries that are pulling up the average falsely. And so in this situation, it'd be better to use the mode or the most common salary. And so a lot of times you'll see this in advertising with certain companies, like you'll make an average of blah, blah, blah a year. But really, you want to know what is the mode salary, what are most people making, because that average can be really misleading if you have a negative skewed curve. So again, here's another example with a study, and I think this is in your book as well. So if you're talking about income per family in thousands of dollars, in one family's here, this is what we call a positively skewed curve, because even though most people here on the low end, it's positively skewed because this high number, the 710, that's 475, is falsely pulling up the average. And so if this were actually a bell curve, a normal bell curve, then 68% of the population would have to fall within this 70, but they don't. Most of the people fall way below it. And so the mean is a terrible measure of central tendency in this case. You'd want to use the mode or the median as measures of central tendency instead. So next we're going to take a look at variance and how that plays into descriptive statistics. It's important to know those central numbers that will describe data like the mean, median, and mode, but it's also important to know how much the scores vary around the center. And there are two terms you need to know with measures of variation. The first is range, and again, this should just hopefully be a simple math term that you've already learned about, but it's simply the difference between the highest data point set and the lowest data point set. And so if you take a look at our numbers right here, the range, I think the lowest number is 5 and the highest is 98, so that gives us a range of 93 points. The other measurement of variance that you need to know is called standard deviation. The standard deviation is the average distance of each data point from the center. Okay, basically it's how much do the scores vary around the mean. And so you can have a high standard deviation or you can have a low standard deviation. If you have a high standard deviation, that's in this blue graph here. What that means is that there is a large distance of scores around the mean. A smaller standard deviation means that the scores are more concentrated. There's more people closer together that got the same score. So for example, if you take basketball players like Shaq and Kobe, they could have the same mean at 30 points per game, but their standard deviations might be very different. Maybe Shaq is scoring 30 points, then 32 points, then 28 points, then 31 points, then 29 points. They're all very concentrated around 30. But maybe Kobe is scoring 15 points, then 45 points, then 25 points, then 50 points, then 10 points. And so he still has the same average, but he has a larger standard deviation. The scores are spread out more around the mean. Okay? So in basketball, I would want a player that has a very low standard deviation because I know that they're very consistent from game to game. Would scientists want a bigger small standard deviation? Again, they'd want a small standard deviation because that proves consistency with their data. And so if you look at a normal distribution curve, how are you able to tell where the standard deviations are? There are usually 3 standard deviations in either direction on a normal distribution curve. Here's 1 standard deviation, 2 standard deviations, 3 standard deviations. This is also 1 standard deviation, 2 standard deviations, 3 standard deviations, but we list them as negative. You'll also hear standard deviations called z-scores. So if I say, what percentage of the population falls above 2 positive z-scores above the mean, then you would say 2.1% fall above 2 z-scores above the mean. Okay? Or if I say, what's the percentage of the population that exists between -1 z-score and +1 z-score, then you would say 68% because they are in between these 2 standard deviations here. Okay? So sometimes you might have heard this, maybe if you had like nieces or nephews when you're growing up, like they fall within 1 standard deviation or 2 standard deviations of the mean in terms of their development. So it's really an important thing to make sure you remember. And just here's another example here. So we have 2 test scores for 2 different classes. They have the same average, so their average is 640 and 640. But you can see that Class A has a much lower standard deviation than Class B. Okay, so the scores are much more close together than they are over here. So if I'm a principal, I could look at just the averages and say, oh man, both of these classes are doing okay, right? But over here, this class is actually doing better because most of the people are stuck together, while over here you have a wide range of scores. And just an interesting fact, I know homecoming's coming up and you're probably thinking about dating people or whatever, but according to Neil Clark Warren, who is the founder of eHarmony.com, he says a couple needs to be within 1 standard deviation of each other in intelligence. Or if you haven't asked anybody yet, you can use this awesome AP Psychology pickup line and tell them that they are 3 standard deviations above the norm, which is 0.1% of the population, really rare. Okay, so the last thing we need to cover are inferential statistics. So what are inferential statistics? They are when you try and generalize your data for all of the population. Okay, so if I do a study here at Bethel and I get data, I can use descriptive statistics to describe that data. But if I want to use inferential statistics, that means that I'm going to try and generalize that data for all high school students in the United States or all high school students in Ohio. And there are certain things that I need to make sure it meets in order to do that. And the one thing it needs to meet is this thing called statistical significance. And so this is the example that I want to use to show you what statistical significance is. So let's say at Bethel we do a study on caffeine and if it improves our reaction time. So we give 40 people, we get 40 people for the study, and then we give 20 the caffeine pill, 20 the placebo, and then we do the reaction test and we determine, yes, the people with the caffeine, they definitely have quicker reaction time. But we can't stop there. We have to determine, is it statistically significant? And what statistical significance means is it's the chance that your results happened by chance. So yes, we did figure out that caffeine improved the reaction time in our study. But did it actually improve the reaction time, or was that just dumb luck? Did it happen by chance that the results tended to come out that way? So, statistical significance, like I said, means that it doesn't happen by chance, and the value in psychology is 5%. So basically what you have to do is a thing called a t-test, and you don't need to know how to do the t-test. But when you plug in all your data points for a t-test, you get a number, and it's a p-value. And the number has to be less than 5%. If the number is less than 5%, then we consider those results to be statistically significant, meaning that we can generalize that data for the population. If the number is more than 5%, then we say the experiment is null, the hypothesis is null, and we cannot publish that data for a population. So it's really important that you remember that 5%. So with our test results, let's say with our caffeine study, we get a p-value of 0.039. What that means is that there's a 3.9% that those results happen by chance. So if we did this study 100 different times, 3.9% of the times that we did that, or 3.9 times, those results would probably happen by chance. Okay? So that's statistical significance. And so hopefully you got a better understanding of what descriptive and inferential statistics were in this video. We're going to practice them a lot in class tomorrow, so if you're confused, please bring your questions and I will get them answered for you. Have a good night, and I'll see you tomorrow.